Thank you, Paola. Good morning, everyone. So today I'm excited to present our project Commoning Biomedicine, a digital humanities initiative that aims to improve the way historians access and explore oral history in biomedical research. Currently, there are about 8,000 English language interviews with biomedical experts, patients, and healthcare leaders, half online and half offline. These offer invaluable insights into medical history and advancements, but accessing them has been a significant challenge for researchers. In this context, Promoting Biomedicine aims to facilitate historians' access to oral history in biomedicine. Initiated by the Max Planck Institute for the History of Science, it aims to address the challenges historians face with this current landscape of scattered, underutilized oral history collections. With that in mind, we are developing an online platform that enables scholars to search within and across diverse oral history repositories. A platform supporting mixed methods approaches, combining digital humanities and qualitative historical research to explore new questions using these sources. The challenges we face are multiple. These oral history records are scattered across various media and institutions, each with their own access restrictions. Legal barriers further complicate access. The metadata schemes used by these collections are quite different from each other as well. Moreover, there's a real risk of losing valuable digital resources as websites become unmaintained. Our project aims to address these challenges head-on. The online tool we developed simplifies the process of accessing these diverse oral history collections. Our search engine currently allows users to seamlessly explore more than 1,600 records. We've developed a consistent metadata schemes for storing and presenting information, ensuring that the rich content within each record is easily discoverable. Our user-friendly interface makes navigation intuitive for researchers of all technical background. Our technical approach leverages large language models, or LLMs, for metadata extraction from each oral history record transcript. Initially, we explored traditional natural language processing for metadata extraction, but faced challenges with inconsistent text quality. LLMs, with their large context windows, allow us to better grasp implicit context within the text. Let me walk you through the key components. On the left, we have multiple oral history collections represented by green boxes. These are the primary data sources for our system. Moving to the right, we see a scraping pipeline implemented using the Scrapy Python library. This component extracts data from the oral history collections. The scraped data then flows into two processes: a metadata extractor built with LangChain, which pulls out key information, and a summarizer, also using LangChain, which creates concise summaries of the oral history collections. Both of these components interact with the OpenAI API, specifically GPT 3.5 Turbo, shown at the top of this diagram here. At the center, we have our backend implemented using Django. This serves as the core of our system, managing data flows and processing. On the right side, we see the user-facing components, an admin interface for systems administrators, and a user interface for researchers. Finally, we have two stick figures representing the administrator and researcher roles who interact with their respective interfaces. This architecture allows for efficient processing of oral history records from collection to quality control and curation to analysis with appropriate interfaces for different user roles. As we started to integrate various oral history collections, we recognized the need for a unified metadata structure. The schema you see here evolved organically from our analysis of commonalities across different collections. We designed it to be flexible yet comprehensive, capturing essential elements like participants, media type, and contextual information. We chose to implement this schema using the JSON schema format. This decision allows us to integrate Python tools such as the JSON schema library to our data scraping pipeline for easy validation and compliance checking, ensuring data consistency across our diverse sources. This approach not only standardizes metadata across collections, but also streamlines our metadata validation processes, making integration and analysis of oral histories from multiple sources more efficient and reliable. Implementing LLMs presented its own set of challenges. We had to navigate the choice between proprietary models like those from OpenAI and open source alternatives like GPT-4o. We conducted thorough evaluations tailored to our specific needs, weighting the benefits and drawbacks of each. An issue that became apparent very quickly was that the performance of local models, both in terms of speed and quality of the responses, was not satisfactory. We therefore decided to use OpenAI GPT 3.5 Turbo to perform the metadata extraction and summarization tasks, using LangChain as a way to manage prompt generation as well as output processing. Integrating large language models for summarization presented unique challenges. As you can see on this slide, we faced two primary issues. First, we had to deal with transcripts of varying sizes. Oral histories can range from brief interviews to extensive life stories, requiring a flexible approach to text processing. Second, we needed sophisticated prompt engineering to effectively summarize these diverse transcripts. We implemented a MapReduce strategy to handle this complexity. Below, you can see snippets of our Python code that addresses these challenges. We've implemented a recursive text splitter to handle large documents and a conditional logic to choose between simple summarization for shorter text and a more complex MapReduce approach for longer ones. The code also shows how we're managing token limits, which is crucial when working with LLMs. We calculate the number of tokens in each transcript and compare it to the model's maximum token limit to determine the appropriate summarization method. This approach allows us to efficiently process and summarize oral history transcripts of any length, ensuring we capture the essence of each interview, regardless of its size, and present it to the researchers on an easy-to-use interface. Commoning biomedicine, more generally, is organized around three main outputs. First, we're developing open source website infrastructure, which we call the code part of our output. Second, through collaborations, we're building alliances with other institutions to harmonize oral history metadata and ensure our digital tools are reusable. Lastly, we host conversations. Many workshops focus on oral history research methods and repository management. Researchers at the Institute have started using the platform to produce actual historical research. Here is an example of a paper that will be published very soon in Historical Studies in the Natural Sciences. We launched the Commoning Biomedicine platform on July the 19th, 2023. And currently, we've linked 15 collections of oral histories related to biomedicine, totaling 1,637 transcripts. We're continually working to add more collections. Looking ahead, we envision this platform opening new avenues for research in oral history, enabling scholars to ask and answer novel questions using these oral historical sources. With that aim, starting in autumn 2024, we aim to build upon this platform to expand this model to more disciplines and integrate it to the work our institute is currently doing in establishing an oral history lab. In this context, we plan to add an automated audio transcription module and to expand our code base to turn it into a complete oral history research platform. Thank you very much, and don't hesitate to visit our website. You can see the URL here. Thank you very much. 1 minute.